Hello guys, good morning. Good morning. Welcome to another episode of XR Talk Show. We are going to code emacs lisp today, continued from last episode 2 days ago. Emacs lisp programming language, the best programming language for text processing, best than Perl, Python, Wolfram language, Haskell, F# or Camel, best than any programming language for the task of text processing, okay, which is a giant, huge task. Emacs Lisp. I have so much hand pen, so let me show you my keyboards again. Glove 80, fantastic keyboard. Ultimate Hacking keyboard, fantastic. Nulia trackball, I have a Hoover to activate Windows system, fantastic. This Logitech 502 got the spin wheel, that's the best thing, spin forever. Infinite scroll. Then let me mention this again. I typed so much, I'm gonna become a cripple. The spot that hurts is right here, okay? Let's see, like right here. For me, left hand. So I'm gonna start to learn this again. No guarantees, but this is the most advanced fancy input device. This is called Svalbard, Svalboard. Okay, it's got two pieces. So I have a review for each one of them on YouTube. Now let's begin coding. If you are watching this offline, play at 1.5 speed. 1.5 speed, okay? Because I ramble. Otherwise, if you are here, say hi. Love to see your comments. Love to see your comments. Okay, so let's start to code. Let's see, how many of you are watching? Three is a crowd, counting myself. Okay, I'm using Emacs, the most efficient editor showing browser. This is today's talk show, and I'm using Xarfly keys, which is efficient key binding system for Emacs. There's a video you can watch, so you don't have to press control keys or alt keys or meta. Almost none. Okay, so the most efficient. So more efficient than Vim, NeoVim. Okay, counting keystrokes. If you count keystrokes doing the same thing, Xarfly keys is more efficient than Vim or NeoVim or whatever. Okay, Xarfly keys, that's what I'm using. It's down. You can download for free, of course. You can watch a video, download for free on GitHub. It's also on GNU Alpha. And the pink window shows all my command calls, custom commands, and keystrokes. And I'm using a dvorak keyboard layout, which is close that. Okay, showing browser, dvorak keyboard layout. Okay, that looks like that. Most efficient, so should you switch to it or not? That depends. Okay, there's lots of reasons. For most people, nah, just get a keyboard. If you type 8 hours a day or something for 10 years, 20 years, if you are a programmer or working with computers as a professional, the first most important thing is to get a keyboard with linear light mechanical switches. Okay, key switch guide. So you can look at my keyboard, so get a linear mechanical switch. That's the most important. Okay, you can get any one of these, or you can follow me with these fancy keyboards. Okay, so that's about keyboards. Now let's start to code. Okay, so today's talk show. Now it began. We started continuation from 2 days ago, which I have to go. So this is a code. But before we do that, so what we want to do is to add a ID to HTML div tag. Okay, so for example, you look at this page, JavaScript. Let's go to JavaScript class. Okay, JavaScript tutorial on xari.info. Okay, just go there, then you will see a JavaScript tutorial, JavaScript in depth. Then you go down, you go to the, let's say, strings, okay? String overview, JavaScript string, fairly complicated, you see, because each character is actually code unit from UTF-16, so it's not entirely a character. Anyway, so you see this page, you got this topic box, okay? Copy the URL, go to Emacs, open this file, show in browser, you see that's a file, go back to Emacs, so you see this topic box, wait, I don't want to delete, you see topic box, JavaScript string, then then you got a list of items, show in browser, go to the bottom, you can see that, so we were doing what we want to do is that find all this topic box among the 10,000 HTML, and for each one add a ID attribute like this, okay? Then random string. So if the topic box is the same, for example, this one, so for each one of this page, add the ID attribute to this topic box for each one of these. Now, some other pages, they'll be different. So for example, let's go to JavaScript variable. Okay, you got a topic box, but it's a different topic. Okay, so for all these pages, they need an ID of the same ID. Now, for different topic box, you need a different ID. So you need to go through 10,000 HTML files to add a unique ID for this same topic. Okay, that was what we were doing 2 days ago, but we didn't complete. But one of the key things is that you need this ID string, okay? But okay, so wait, but let's digress, you see, because I want to know, because you know, when you need to add ID, for example, this, you know, you want to avoid collision, so you need to know what is the maximal possible ID values. Okay, let me do it. Let me talk about this issue. Okay. So showing browser, close. Showing browser. That's today's talk show, and we are talking about ID string. Okay. So so we need to add this. Make it code. Cut that. Put here. Showing browser. So we need to add that. You see. So let me expand to each of the topic box like this. Okay, showing browser. You see, that's what we want to do. So, but before you write a code, you need to come up with the ID. How do you get the ID? In my case, I have a command. So let me show you. Press. You see, you got an ID. Press. That command is insert random string. Okay. So you can go. Here is a source code, not too long, but actually it calls random string. So go up here. So this is the random string. So what are the possible characters for random string? They are A to Z and 0 to 9, uppercase and lowercase, but except vowels. So you don't have A, E, I, O, U, upper or lower, nor do you have L and L, uppercase L or lowercase L, nor do you have 0 and 1. So this, why? Because to avoid ambiguity. But why do you, so because L and lowercase L and 1 look similar, and 0 looks similar to the letter O. That's why you don't want them. But what about vowels? What about A, E? But I is also similar to 1 or L. But what about capital I, for example? But what about A, E, and U? Why do you want to remove them? Because when you create a random string, and when there's a vowel, you tend to form a association of a word, sometimes like fuck. You don't want that. It's pretty easy to have a association with a word. So by removing vowels, you don't have that problem. Okay. So, and this code, you can grab the code if you want it yourself. So you got this bunch of functions to insert random string. You can insert a random number, decimal number, or random hexadecimal number, or random string, or then you have insert UUID. Okay, let's talk about that. Copy. So close. Let me get to it. Okay, so paste that and insert random UUID. Let me demo. Okay, copy that, paste, link them both, make a list, and this make a text. Okay, now showing browser. So you got insert random UUID and insert random string. You can get the code and use them. Fantastic. Thank you, Kasa. If you like my stuff, donate. Okay, grab the code and donate. $100 if you have a job. If you work at Google or something, put $999. By the way, someone wants to buy my website. I sell for $300. I send you a zip code. It's about 6,000 unique files, essays, computer language tutorials, or mathematics. So, but I haven't sent it yet. Okay, I need to generate it. I make sure I generate a new one. So, okay, so wait for it. So Walter says, I tried to switch to dvorak. It almost broke my mind. I got dizzy trying to practice. I gave up. Yeah, it's not necessary. Okay, so I learned dvorak back in 1993 because I'm obsessed with efficiency. When I learned about the QWERTY layout, it's like fucked up. Just why is the letter arranged QWERTY ASDF, why is it that way? Oh, because back then, about 200 years ago, they want to avoid key jam, so they put some frequent words in like different places so they avoid key jam, but not for making you type faster, because if you type fast, they're gonna jam, they're gonna make you slow. Actually specific for that purpose. You go online, you read about it. There's lots of myth and conflict information. Some say, oh, QWERTY is actually not designed to slow you down, but actually it is. The way our letter arrangement are on standard keyboard, that's called QWERTY, because the first row is QWERTY. Okay, invented some 200 years ago. It is that way because, in a sense, it's because to prevent people typing fast. Okay, that's basically the bottom line. But you look online, you have thousands conflicting info. Some say you are wrong. No, you are wrong. Okay, ignore them. So that's what we got. Lots of histories like that. Like, for example, in programming languages, why we have the Unix, the complicated bag of shit, because history and C and all that. History, okay? We can't just change it overnight because we have habits, for example, if you change the keyboard, nobody knows how to type anymore. You're gonna relearn, everyone. We don't want to learn new things. We want, we want just to get on. So habit is a powerful force. So, and the traditional math notation, the traditional music notation, the 5 lines musical staff, it's all kind of convention, and including English language, tons of bad spelling. I read it, and lots of problems, orthography, and lots of issues, illogical. But we cannot change it, and there's habit involved. So, so anyway, on the keyboard, so you got the QWERTY layout. I mean, then you got the dvorak layout. Okay, let's talk about that a little bit. So digress, dvorak layout. Okay, So let me show you the page. Ergonomic keyboard layout. So it's this page is all the layouts that exist. You see QWERTY, you see dvorak, you see QWERTY is the bigger the circle, the more frequent is that key. Okay. Now if you look at QWERTY, it's all over. But if you look at dvorak, it's better design. All the most frequently used keys are under your fingers. Then you got Comac, then you got QFM, you got Walkman. So you got a lot of new ones. But the question is, should you relearn any one of these new? For most people, no. Okay, it's not worth it. Okay, that's my view. I talk about this almost every week for 3 years. So in my old tutorial, in my old videos, let's say 2 or 3 years ago, you'll see I talk about this almost every week. Okay, so let's not talk about that keyboard stuff. So that's about keyboard layout and stuff and efficiency. Now back to the random string. Okay, so you have seen I want to insert the random string. So one of the common random string in computer industry, a standard is called UUID. It stands for something like universal something ID. Okay, so we can insert that. Let's see. The key, insert a random string. Okay, random string. Insert a random digit. Random number. Let's say I want 10 digit. Let's say I want 9 digits of a random decimal number. Okay, so press that 9, then press this. Wait, I press it wrong. Press 9 universal argument 9, then there it is. Now select it and call how many count words. So you got 9 characters. You can see in the bottom 9 characters. Let's say I want 20 characters. Okay, press that key 20. Press that key 20, then press the key to insert the random decimal number, which is this. You see, now you got 20 digits. Same thing with the random string. Now let's say I want 20 digits. Okay, so universal argument 20, then you got 20 random string. Okay, all the command names you can see on the pink window. Okay, so random string, random number. What about random hexadecimal? Okay, you can do it like that. Okay, that. What about 20 digits of it? Okay, universal argument 20, that. There you go. Hexadecimal. Okay, 16-base number system. So that are all these commands. It's all here. Okay. So what about UUID? Okay, let's insert that. So I believe the key is that. No, I forgot what is a key. So you can press show all keys and search for UUID. There it is. Okay. Insert random UUID. Delete TZ. Okay. Delete TZ. There it is. Delete TZ. Okay. Delete TZ. Okay. This is a standard random string called UUID. So it's got basically a specific format of 32 digits of hexadecimal. Okay, that's UUID. Now this is random hexadecimal. Okay, let's comment it so make it clear what we're doing. Now this is random decimal, okay, and this part is random string. Okay, now put it back, show in browser. So we got some examples of random string. Now there's a question. When you design a random ID such as in YouTube, so if you notice every time you go to YouTube, there is this, random sequence of characters. That's their ID. That's basically each YouTube video got this ID. So this is today's talk show. So this is recursive. This is me talking right now. Okay, close it. So you see YouTube got ID. Similarly for Twitter, every time you make a post, you see there is this guy. This is related to computer science, our topic today. There's this guy, Peter Landin. I started to really dislike this guy. He's dead by now. He's like, he died 20 years ago. He's a computer scientist, okay? I started to not like him because I learned he did a great damage in programming language syntax, in particularly in the functional programming languages, Meta language, ML, or Haskell, or Camel, Rust, and Python. He created, the Python indentation syntax that's partially came from this guy, okay? And the OCaml's let, the Haskell OCaml meta language, the let something also came from this guy. And this guy is kind of a troll, okay, the Peter Landin. Why? Because he wrote the article, the next 700 programming languages. He's gonna tell you this thing, I'm gonna create a syntax for the next 700 programming languages. A grifter, okay, a clickbait grifter. This guy, seems a smart guy, Peter Landin. I never heard of him much because he didn't actually create any language, but he's a computer scientist. Okay, so I started to not like him. But back to our topic. You see, each post got this ID. You see, copy that. Okay, so you see, sample x.com ID. Okay, and today's talk show. Where is it here? Okay, then sample YouTube ID. You see, so that's just for references purposes. So we got ID. So but when you design your ID, you want to know how many possible digits are there. I mean, how many possibilities are there, because you don't want collision. So for example, in the Twitter case, that's really low. How many digits is that? press 19 characters. So it's only got 19 characters. So 19 characters is like that's not much. You're gonna have collision. That's interesting. Oh, okay. So each person by person. Okay. So for each person, you might have this many possible posts. So if you post one message per second, for example, one message per second, so 60 second. Let's do some random coding and chat. Okay, 60 second. So you got 24 hours. Each hour is 60 minutes. Each minute is 60 seconds. Okay, let's compute that. How many is that? Wolfram language takes a while, so that's that many. Okay, now but if you do this 335 every day, you do this let's say 1 second per post for a year. Okay, what do you get? Show me. Okay, so you only got that. So if you do this for 10 years, then you just add 0, right? So that's not much. So okay, let's show in browser. Okay, so show in browser. So Twitter's, let's see, where is Twitter? Twitter's ID seems sufficient, because if you post 1 second per post for a year, you only get this much. And Twitter ID is like how many, 19 digits. So that's sufficient. If you post 1 second per post for 100 years, you would not reach the maximum of Twitter. But wait, but these are random numbers, so you still have possibility of collision because these are not sequential. But anyway, okay, these are the issues about identifier, about random identifier design issues. Okay, random identifier design. And for that, you can look into our article. Okay, so I digress so much. Where's the article? So we are talking about random ID design. Okay, there it is. Okay, so this article dive into detail about what are the total possibilities of a random string design. If you are doing YouTube, if you are going to create a YouTube website or Twitter or anything, you need a random string. Like how many digits are you gonna have, and also what is your base? You see, one thing interesting about YouTube is that they include the underscore. You see, they also include dash, and you can see they also include vowels. So there are 26 English letters, upper and lower case together is 52 possibilities, plus 10 digits 0 to 9, so 52 plus 10, 62. So you got 62 base called radix. Okay, that's called radix. Okay, 62. But in the YouTube case, then you also got underscore. Okay, they also include underscore and dash. So you got 62 plus 2, 64 base, something like that. Okay. Then you want to know, then depends on how many digits you have total, then you can know what is the potential. Then you have to think about how many videos each person creates a day, things like that you have to consider. Okay, so that's about random string design. Okay, design of random. Let me type it. Okay, a new section, design of random ID system of random sequence of characters. Okay, then move that down. Okay, and we want, okay, cut. Let me tell you what's going on. You'll see. So we are talking about, okay, so we got a new section now cleaned up about design of random sequence of characters for an ID system. So now we need to look at this article. So right now the question is, if I'm going to design an ID system for my div tag, I know my base, my radix is I think 50, 26 letters plus digits minus the vowels and minus 0 and 1. That's 48. Okay, so my radix is 48. So how many digits do I need? That's the question, because I want to avoid collision. Okay, so that's when you need to look at this article. Okay, so for example, why don't we why don't we just compute it? Okay, so that we make this much more clear for those who are later on watching this. Am I good? It's interesting. So first of all, Huang says, do you think Sufa is difficult? You are talking about Sufa, which is Chinese calligraphy, which is the Chinese tradition of using a brush pen to write Chinese characters. That's Chinese calligraphy, aka, Sufa. I want to make some for women, for your girlfriend. Yeah, you can do that. That would be fun. But Chinese calligraphy is useless. It's kind of idiotic. Okay, first of all, Chinese calligraphy. Now, if you are a white guy or Western guy, if you are not Chinese, then you don't know what I'm talking about. Okay, but for Chinese and Japanese or Korean, well, mostly Chinese and Japanese still kind of do it. It's a tradition. It's a cultural tradition and art. Okay, and you kind of also learn some kind of discipline because every day. So, have you guys seen a Chinese when I was in school, age 10 years old, I have to do this. Lots of Chinese have to do this Chinese calligraphy. Okay, so let me just show pictures. So kind of like that, okay, this is how you do it. So you use a brush pen, basically you write Chinese, and you just keep doing it. So you kind of develop a style, and some of them are beautiful. So there are many kind of styles, so these are called Chinese calligraphy. So you see, this is more fancy one. There are many different styles. Okay, Chinese calligraphy. So it's kind of similar to English. Let's see. Let's do a screenshot. Do a massive screenshot. So let's digress and demo calligraphy. Okay, so snip as so it's like similar to English, English, English cursive. So, but in Western tradition, you don't use a brush pen. So what you use is this. What's the name of that pen? Ink. You have to dip ink pen. You have to. I forgot. But it's another topic. Okay. So that's about Chinese calligraphy. So it is a tradition. Okay. So wait. Save. Yes, save. Okay. It's a tradition, Chinese tradition. So you kind of learn, if you are Chinese or Japanese, you kind of learn tradition. That's how you learn your culture. That's how you develop a sense of your bloodline. Okay, just like the white people, they have, their things like Rome and. But the question is this good? No. Well, it's good in some way, but it's useless. Okay, what you want to do is rocket science, not calligraphy. Okay, you doing Chinese calligraphy does not make China great. You doing English, cursive writing, the art of cursive writing, does not make America great again. Okay, you wanna do rocket science, you wanna do emacs, you want to do coding. Okay. That's the thing. So is it good? Well, you can learn it, as a habit, or that's fine, but it's useless basically for modern society. So you wanna show that to your girlfriend? Yeah, you can do that. So AZ says just use a collision resistant ID package. No, that's not good because you just shove the problem into other people and you rely on other people's solution. And what is a collision resistant ID package? IDs are typically assigned by the database. No need to design an ID. That's totally wrong. Where do you think the database ID came from? Somebody has to design it. Thank you. Anything? And okay, cool. I'm personally here for programming content. Okay, so I'm back to you see, we need to be polymath. You see, the other problem with coding is just that you got lots of nerds. Then you started to know nothing else about society. You don't know how society works. All you know is like coding, bit diddling, or mathematics, but then you became this narrow. You lost the sense of humanity. You lost the purpose. You lost the appreciation of beauty. You don't know why you are here. You ignored philosophy or arts. So that's the other problem. Okay. So anyway, let's go back to coding. Okay. So ID characters design. So we back to So you can actually. So for example, so one way to be safe is just based on the UUID. Okay, so UUID is because UUID, where is our example? Where is it? Show it. So UUID is this 32 hexadecimal digits, 32 of them. So whatever that should be enough, because UUID is designed such that if everyone every second create 10,000 UUID, it's not likely to collide because the numbers are too big. Okay, so whatever you are designing, if you make it to be the same number of possibilities of your UUID, then it's good. Okay, so we can see UUID is 16 base. Okay, so 16, and how many of them? 32 of them. Okay, so 32. So the total is 3 followed basically a number of 38 digits. Okay, that's more than the atoms in the universe, something like that. So system B, if you base on just English letters, 26 of them, then how many you need? You need a lot. Okay, you need like let's say you need about 27 to 28 number of digits. Okay, so you kind of save 5 digits. So you see, what we want is that we want the same number of possibilities, but we want to have a smaller string as much as possible. That's a desired thing. But however, the issue is that if you look at, if you read this article, the graph is that if you just increase one more digit, that gives you a lot more possibilities. But if you increase the base, they don't grow much. Okay, so if you want the more possibilities, you need to increase the number of digits. Okay, so but what we're gonna do today is something novel. We want to let's just start to write emacs Lisp code. Okay, so we want to do let's begin write emacs code. Okay, so D for define, char insert random Chinese char. Okay, so we are going to use Chinese characters for ID system because Chinese characters, they are like, depending on how you count, there are 3,000 common ones, but if you count all, there are like 10 or 20,000 of it. So one single Chinese random character is like already 10,000 possibilities. Okay, so it's not like English. One English random letter is 1 out of 26 possibilities, but one random Chinese character is, like 10,000 possibilities. Okay, wait, go back. Wait, where did we go? Yeah. Okay, let's write this. Okay. Insert random Chinese char, 5 of them, let's just say. Okay, for now. Okay, so first of all, what you need to know is the range of Chinese characters in Unicode. Okay, save it. So let me show you Chinese characters. Unicode xali.info. You'll find the Unicode page. Then there is the Chinese. Okay, there's some sample Chinese characters. Okay, copy that, close that, paste that. Okay, then but what you need to know is I need to know the Unicode range. I don't know what it is. So let's look up Wikipedia Chinese encoding. No, Big Five. Okay, convention. Unicode hand unification. Okay, open that one. Guobiao. Okay, we don't care about that. We want the Unicode Chinese encoding. Okay, code page. No. So let's go to this page. Hand unification. Unicode universal character set. Hand characters. Okay. Which is used in Chinese characters, used in also Japan, Korea, and Vietnamese. Okay, but what is the range? Let's just search for Unicode hand block, CJK block. You'll find it directly. There it is. Unicode block CJK stand for Chinese, Japanese, Korea. Okay. So it's from, there it is. So there are 20 of them, 20,000 of them. Can you see? Copy that. Okay. So copy that. Link, list. Okay. Unicode Chinese characters block. And this is the range. Copy that. Go to our code and paste that range. Okay. There are 20,000 of it. Okay, so this is the range. Now I need to know what is the decimal. Okay, I don't want the Unicode format. So what is a decimal? You can do in Emacs is that yeah. Okay, so eval. Wait, not that. So this should be $X. Okay. There it is. This is a decimal, okay? And what about this? So you can look at the pink window to see what I'm calling eval last 6. Okay, this because this works because this $X means the hexadecimal input. Okay, so that is that. Okay, so the range is this to this. Okay, so now we call random limit. Okay, so random limit. So what we need to do is, okay, so let's start end C start C end. Okay, something like that. Okay, let's set it. Okay, so C start. Okay, hold on a second. So C start will be just that. Set that. Okay, and C end will be that. Okay, now Okay, now we got C start and C end, then random. I want the random number, please. Random number from C end minus C end minus C start. Okay, and yeah, create a random, then plus C start. Okay, so plus C start there. Okay, so that gives you a random character. Now if you it actually gives you a random number. Okay, now in Emacs a integer is also means character, so you need to turn this integer to a character. So let's just say insert char ID. Okay, so char ID, wait, set what set char ID that. Okay, char ID equals to that, then insert char to string char ID. Okay, prettify the code. That's it. That is the code. Okay, so evaluate the buffer. Now meta x char insert random Chinese char. There we go. Fantastic. Now we need to do this 5 times. Okay, so let's just quickly code it. Okay, do times 5. I is a variable, result we don't care, and delete that, and the body will be PG program that groups these two together. Okay, copy that, paste, prettify the code. There it is. Do times I from 5 times. Okay, we don't actually care about the variable. Do it 5 times, generate a char ID. In fact, we don't need this variable. Okay, so char ID, delete it, remove that, cut that, and just move this thing to here. Okay, and in fact char to string we don't need it. Let's just say format. Okay, because format 96 is lowercase a. Try it. No. Okay, so you need to say char, format char. No, 95 I believe, or is it 65? Okay, 65. No, this ASCII code guessing. Okay, 65 is the ID for capital A. There we have it. Okay, so you can just say format C. Okay, so let's do it. So format C, all we have to do is just say format C, and then here you just give it a number there. Okay, then you don't need that, then, but actually you need to say insert. Okay, prettify the code. There it is. Prettify, remove that, prettify. Fantastic. Evaluate the buffer. Now call, do it. Oh, do it again. Fantastic. Okay, insert 5 of them. Okay, so we got the code. Sample output. Okay, put it back, syntax correct, show in browser. So today's fruit is exploration of this function to insert random Chinese characters. But how many are there? So let's see. We forgot to check how many are there. So each letter is wow, let's check. Okay, char calculator. Okay, so this is my char calculator. Fantastic. So we want yeah, so that minus that. Okay, we don't care about that. print, that evaluate. So we got 20,000. Wait. Oh, so you need that, then times 5, because you got 5 of it. Okay. The others we don't care. What I was doing, this is my calculator pad. Okay, I talked about this. So anyway, run it. So this you got 10,000. Okay, so that's not enough. Not times 5. This is a power. Should be power. Yeah. 5th power. So that's why. So the power in Emacs is exp, I think. Well, go to Emacs Lisp. Go to the Lisp basics, string, number, arithmetics. How do you do power? EXPT. Okay, it's always annoying when your programming language don't have the correct for power. Okay, EXPT. Wait, why is it EXPT? I don't even have it. Does a what? Oh wait, I'm in Python. Wow, fucking idiotic. In Python, the power is just double asterisk. Okay, run it. Fine. That is what we're looking for. This is the. Okay, so save it, close. Now let's create a Python code, paste it there, pop out, comment. This is possible. This is possibilities of 5 Chinese chars in Unicode CJK block range. Okay, syntax correct, showing browser. So that's what we got, and this is fantastic. Only 5 Chinese characters, and then you got this many. This many is even bigger than Twitter's. Bigger than Twitter's ID count. Where's Twitter? You see? Wait, Twitter compare. So copy that. Python. Let's say Twitter. You see? It's 3 digits bigger than Twitter's. So this is sufficient. This is beautiful. So we got a fantastic new ID design of Chinese characters, just 5 of them. And usually when you do this, because in practice each Chinese knows on average 3,000 characters to 5,000. 5,000 is kind of tops, just like English. Okay, in English, when you read a newspaper, common college educated people, you need 3,000 words. Same thing in Chinese. But however, Chinese got 10,000 characters or more. So when you create, when you generate a random character sequence of Chinese, like most of the time, all the words you don't know. Okay, actually, I know some of them. I know like half of them. I mean, for average people, but the other half, like you never seen the word before. So anyway, this is fantastic. Fantastic new ID design using Chinese chars. Okay. Now, what are the possible flaws of this system? Well, for one thing, you need Unicode encoding. Which is very popular today, UTF-8, and also you kind of need Chinese font, but which is also very popular by default in Mac or in any system. You have Chinese font, but however, using Chinese encoding, I mean, if you are dealing with ASCII low-level stuff, usually you don't want that, because then it involves decoding the Unicode. On the other hand, if you just use ASCII characters for random string, then any low-level assembly, even C language, they have libraries to read hexadecimal. They don't need to go through Unicode decoding. But however, if you are creating like in a high-level design application, this is pretty good, very short, and you have lots of possibilities. So, for example, compared to Twitter, you got, every time you post, you got these 19 digits. Or the YouTube, like then you need capital, some are capital case, some are lowercase, okay, so that's kind of, I think that's a digression we did, but that's a good one, talking about the ID character system, okay? It's a good digression. As far as the task about which we did about, adding the ID to the div, that's not too interesting. And we did similar before, we did so many videos before, but I might do this offline, or because I got lots of other topics. Tomorrow I want to go back to Wolfram language coding, lots of topics, machine learning, Lean proof system, F#, programming, lots of other things. Okay, so I think that's it for today. Thank you guys for watching. Don't forget to donate to me. Okay, so you can go to xali.info. My website for programming stuff is called Xacode. Go to the bottom. You PayPal me, Patreon me, PayPal $100, Amazon gift card. Okay. Thank you. Make me happy. Okay. So, or you can, if you want my, you can buy my entire Emacs Lisp and Emacs tutorial for $30 something, 32. I'll send you the zip file so that you can have a easy reference when you learn Emacs Lisp. Similarly, I also have one for JavaScript in depth. For Emacs Lisp, for example, you go to Emacs Lisp, then you go to there, buy Emacs tutorial, okay? Then I'll mail it to you. Or if you prefer JavaScript, if you are a web dev, I also have one for JavaScript in depth. This is actually more comprehensive than my Emacs Lisp tutorial. So all the way down, you can see where to buy there. Buy, I'll send you a copy so you can kind of use it for reference. It's great for reference because you click on the JavaScript global reference, you got object, which is a class, object class. Then you got object constructor details. Then you got object.prototype, so you got object create, object assign, object get prototype of. These are static methods. Then you go to object prototype. Then these are the methods, the methods. So you got a few of them, has own property, is prototype, prototype is number. So, but if you go back to, for example, array, you got array constructors, fairly complex array constructors. Then you got array properties, prototype. These are static properties, okay? Then, but if you go to prototype, these are dynamic methods. These are the used most common. For example, push, pop, shift, unshift, splice, and concact, slice, get the keys and map for each filter, very frequently used. So this is about my JavaScript tutorial, the reference section, and regular expression, the entire documentation of regular expression, and so on. So for example, regular expression syntax, very complex topic. Okay, and it's fully documented and with lots of examples. For example, you got this new Unicode property. So if you want to get Unicode, let's say you want to grab all emojis in a file, then you need to use this Unicode regular expression, so I got the examples for that too. So that's my JavaScript in depth, okay? So check it out, donate to me, thank you. Or if you want to have a local copy, you can pay a few bucks and get it. Anything else? That's it for today. So let's go back. Let's see the comments and we shut down. No comments. No comments. What the fuck? AZ says, if you create an app today, would you design your own ID? Would you also design the rest of the database? And do you design ID for every single table in the database? Feel like reinventing the wheel? Of course you don't. Of course you don't. In fact, if you are industrial coder, professional coders, you don't need to know even computer science algorithms, because hash table, array, sorting, that's big computer science, or searching string, how do you implement regular expression? You don't need to know none of that. You can be a professional coder for Python or even for machine learning, and you don't need to know about these things. But however, I am a lot of time doing random programming, technical topics, computer or science or mathematics or theoretical computer science and stuff, pattern matching and functional programming and proof systems and type systems. So that's why I'm talking about this kind of interesting topics about ID design. But in fact, today we created this Chinese random ID. In fact, I think that's useful, okay? It will be, I think it is, I would say 50% of chance, okay? 50% of chance that in 5 or 10 years, this will be popular, okay? Because the advantage of this is because it's pretty short and you avoid a lot of collision, okay? So this is actually a practical application, but I mean, not practical like you need it now, but I think there's a big potential, down 5 or 10 years, you might start to see IDs that comes in this form, okay, just like a bunch of Unicode random Chinese characters. And Chinese characters among the Unicode, all the Unicode characters, they are like, I don't know, 30,000 of them. Chinese is actually the most suitable, because when you talk about Unicode, you could also, let's try, why not, let's use all the emojis, okay? So for example, where is it? Let's use all the emojis, for example, so include all emojis, and why not let's also include all arrow keys. So there are like 50 type of arrows or different, and also let's include all this exotic alphabet, Deseret, which is phonetic based alphabet created by the Mormons, Christian, kind of Christian, okay, Mormons. Or let's include all the Greek letters, okay, or include the IPA phonetic symbols, for pronunciation. Dad, iPod, iPad, iDad, phonetic symbols. Or let's include historical or chemical symbols. You see, but the problem is, if you include this, there are not many, 50, 100. They don't give you this kind of brevity in the Chinese characters. And for the Chinese characters, there's no upper and lower case. That's very kind of nasty thing. Because when you have uppercase and lowercase for the same character, then you start to get into the complexities of, whether, in this file system, it's case insensitive, but in that language is case sensitive. You can have these complex issues. You see, for example, the YouTube ID, they have some lowercase, some capital case. But for some reason, let's say you need to save each YouTube video as a file. But in Mac and on Windows, the file system are not case sensitive by default. So the same ID sometimes becomes, they act, the same YouTube ID string, they differ by case. So they meant to be different ID, but on a file system, they become the same file. So that's a problem. So you start to have, you may get into a problem. But when you use Chinese characters, you don't have that problem. Also, another example. So here's Greek, for example. Here's Greek and variations. You have actually, this italic and bold. They are not font variations. They are not, style variation. They are actual Unicode characters. So you can include Greeks, that would total of 100 characters, or you can include Cyrillic, the Russian alphabet, or you can include Japanese phonetic symbols, the katakana and stuff. But one problem is Arabic. You don't want that, because Arabic, if you use these as random characters, they got right to left problem. So so it's very it's not so good, because either you stick with right to left or left to right. If you mix them, it's not so good. Okay, so that's my random comments about that. Okay, bye guys. So bye.